we start. Hey guys, welcome back. Yeah guys, so today is day 7, no? Day 7th of the 100 days challenge. So today's topic is collision. So we'll see what is the collision and what are the types of collision and some examples of the different type of the collisions. Okay. So first we'll go into the class. The first thing, collision of a body. So collision of a body is said to take place when either like two bodies physically collide with each other, or else the path of one body is changed due to the influence of the other body. See, for example, a one-way road is there. So two cars are coming opposite to each other, right? So they are coming and dashing each other. What is that? Two bodies physically collide with each other. The second way is a car is standing here, there in a road, one more car is coming and dashing that car. Due to that, the second car which is at rest will be moving, right? That is the path of one body is changed due to the influence of the other body or another body. Okay. So during collision, a momentum and kinetic energy of the interacting bodies may changes. Okay. So like a body is at rest, no, like the car 2 is at rest, the car 1 coming at 100 kilometer per hour, but we can't exactly say that the car 2 will also move with 100 kilometer per hour after dashing, right? So it may changes. The force involved are action reaction forces, like action and reaction forces, like equal and opposite reaction, will say, no, action and reaction forces, that is internal forces of the system. Okay, this about the collision of the bodies, and during collision what happens also we have seen, right? So main thing you should keep in mind, like the momentum and then the kinetic energy. Okay, whenever we are talking about the collision of the bodies, one thing is momentum and second thing is kinetic energy of the body. Yes, next one is the types of collision, like according to the direction of the collision we are talking. Okay, first one is head-on collision. So head-on collision is nothing but the direction of a velocity of a body is similar to the direction of the collision. Like a body is there in x-axis, for example, a second body is coming and hitting the first body, so that first body is also moving with the same x-axis. So head-on collision will say, like see here, if you see this picture, no, like a body 2, like mass 2 is there and mass 1 is there of body 1 and body 2, which is going with velocity u1 and velocity u2. Okay, after collision, like the body goes in the same direction, okay, but the velocity changes here, that is v1 and v2. Okay, so before collision, two bodies A and B with masses m1 and m2 moves with initial velocity u1 and u2 respectively. So whatever given here, no, that one only I have written. Okay, so masses m1 m2. So for mass m1 it is u1, for mass m2 it is u2. Next, after collision it is v1 and v2, it's v1 and v2. Okay, what is u1 here? What is u here? Initial velocity. Initial velocity, and v is nothing but final velocity. Final velocity. Okay, so initial velocity of a mass 1 and final velocity of a mass 1, u1 and v1, and u2 and v2 are initial velocity of mass 2, final velocity of mass 2. So next is oblique collision, like direction of velocity of a body is not similar to the direction of the collision. So when the mass 1 no is coming with u1 and hitting the mass 2, so it's going in different angles, okay, making some angle theta or phi, whatever it is, and this is the velocity v1 and v2. Okay, v1 and v2. So I can say that two collisions are there. One is head-on collision and second one is oblique collision. Okay, when the second one is makes an angle theta are said to be oblique collision. Okay. So the types of collision according to the conservation of law of kinetic energy. So first thing is elastic collision. So according to law of kinetic energy, no, like for example, elastic in the sense, no, like I am throwing a ball to a wall. Okay, if a ball come exactly with the same speed, no, I am throwing with 2 meter per second. Okay, 2 meter per second. If it's coming with 2 meter per second, I can say it's elastic. Yes or no? Like exactly it's coming back. So the momentum and the kinetic energy are conserved here, and body is rebounded after collision. So conserved in the sense, what it means? No loss of energy, kinetic energy. Okay, if like not conserved means, for example, I am throwing a ball. Okay, throwing a ball. Shot put you have seen, no? Shot put, like iron ball. I am throwing a ball to the wall. Okay, like little bit it's bounce back. For example, we'll think that, but exactly it won't come with the same velocity. What happens there? Exactly like loss of energy happens. Due, like the energy is converted to heat energy, no? Like kinetic energy is converted to heat energy. So that's what they are saying. Both momentum and kinetic energy are conserved. Next, bodies rebound after collision. Okay, so no loss in total kinetic energy. So examples are given here: ball bouncing without energy loss and atomic or molecular level collisions. Okay, so I didn't give the derivations here, but I have given the formula, direct formula here. You can note this formula for momentum: m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2, where this is for the before collision and this is after collision. Okay, this is before collision and after collision. Similarly for kinetic energy, like we know the kinetic energy formula, no, of m v square, right? There is the kinetic energy formula. So for initial kinetic energy, no, for the collision, of m1 u1 square plus of m2 u2 square, which is equals to of m1 u1 square plus of m2 u2 square. Okay, these are the formula you should remember when you are dealing with the elastic collision. Okay, yeah. Next is inelastic collision and the perfectly inelastic collision. So inelastic collision in the sense, like the same exact velocity it won't come back, but it will come back. Okay, but perfectly inelastic collision means there is a sticking wall. Okay, like clay wall is there. I am throwing a ball to that. What happens there? A ball will stick on the wall. It won't come back. Like exactly perfectly inelastic collision we can say, right? So only momentum is conserved for inelastic collision. Momentum is conserved. Kinetic energy is not conserved there. Like energy will be lodged there. Okay. Some kinetic energy is converted to sound, heat or deformation. I have given for the example for heat energy, no, right? Bodies may or may not stick together. Okay, may or may not. Example, a clay ball hitting the wall and falling down, or car crashing with a damage. Okay, so third thing is perfectly inelastic collision. Like special cases of inelastic collisions, the same example I told, like clay. Okay, like here they told that hitting a wall and falling down, but sometimes it won't fall down also, right? It will be sticking as it is. Then a body stick together after collision, maximum loss of kinetic energy. Yes, maximum loss of kinetic energy will be there here. Okay, almost every energy will be converted to either sound, heat or deformation. So still momentum is conserved. So every cases what we can observe, momentum is conserved, but kinetic energy is not conserved. In elastic, kinetic energy is conserved, right? Example, bullet embedding into the wooden block. So what it means, like a wooden block is there, I am shooting the wooden block. Okay, the bullet is going and stuck inside, right? So it won't come back, no. It's like it's try to stop the bullet, no, like wooden block tries to stop the bullet. That's what they are saying here. So bullets embedding into the wooden block. Next, so one thing is like coefficient of restitution. Like we have seen two formula. The third important formula is coefficient of restitution, which is denoted by E. Okay, like E is nothing but it's the ratio of relative velocity of after collision and relative velocity before collision. Okay, like if you see here, no, yeah, in this case if you see here, like this is the velocity of initial case and this is the velocity of final case. What I can say here, yeah, so u1, okay, U1 is going with mass M1 and mass M2 is going with U2, right? Okay. So after collision, V2 and V1 are V1 and V2. M1, M2. Okay. So relative velocity I should take. Relative velocity is, we have seen in the before classes, no? Like if VAB is there, what is the relative velocity? VA minus VB. So similarly, I should take for the V1 and V2, U1 and U2 for this case. Okay. This is about the coefficient of restitution. It's nothing but ratio of relative velocity after collision by before collision. So there is a 3 cases where E is equals to 1 for elastic. So perfectly elastic means E is equals to 1 where momentum and kinetic energy is conserved. So perfectly inelastic in the sense E is equals to 0, like momentum is conserved but kinetic energy is totally not conserved. So general inelastic collision, like we have seen, no, in this case inelastic collision where a clay ball hitting the wall and falling down. In this case I can say that E is between 0 and 1. Okay. These 3 things you should remember. For elastic, E is equals to 1, perfectly inelastic, E is equals to 0, general inelastic is like E is between 0 and 1. Okay. Next one is head-on elastic collision. Like we will see what is the detailed about head-on elastic collision. Like head-on elastic collision is a straight line collision between the 2 bodies. So we have seen the first one is head-on collision, second one is oblique collision. As I said, it is a straight line collision between the 2 bodies. So both momentum and kinetic energy are conserved, bodies move along the same axis. So I have told about that, I have taken only x axis. So I can say that bodies move along the same axis. So for body is moving like M1, U1, M2, U2. Okay. If M1 is hitting M2, the axis won't change, it will go in the same axis. So condition for head-on collision, there is some conditions. So motion is collinear, okay, like along the same straight line. Okay, this is the first condition. Second condition is no external force during the collision. Third one is the law of conservation of linear momentum as well as kinetic energy. Like whatever we have seen in the previous slide, same thing, like linear momentum and the kinetic energy. Okay. Now these are the formulas. Like momentum we have seen M1 U1 plus M2 U2 equals to M1 V1 plus M2 V2, and then kinetic energy same, of M1 U1 square plus of M2 U2 square should be equals to of M1 V1 square plus of M2 V2 square. Okay. And then if they are asking about what is the velocity after collision, that is for V1 as well as V2. Okay. After derivation, this is the formula. By using this equation number 1 and equation number 2, no. Okay. By using these 2 equations, we will get this answer. Okay. So I have not done the derivation, I have gave the formula directly, where we can use V1 V2, that is M1 minus M2 of U1 plus M2 U2, like it's totally divided by M1 plus M2. Okay. You can see here clearly. So there is a square bracket for this one. Okay. So this totally divided by M1 plus M2. Similarly for V2, M2 minus M1 of U2 plus 2 M1 U1 by M1 plus M2. Okay. These are the formulas for the head-on collision. Okay. So there are some special cases, like if mass is equal, suppose M1, M2, body moving with U1 and U2, okay, like different velocity U1 and U2, but what they are saying is mass is equal, M1 equals to M2. In these cases, no, I can interchange the velocities. U1 is nothing but V2, U2 is nothing but V1. Simply I can interchange the velocities if masses are equal only. If mass is not equal, I should use the previous case only. This formulas only I should use, V1 and V2. If mass is equal, I can say directly U1 equals to V2, U2 equals to V1. Next one, special case like heavy second masses. If mass 1 is much less than m2. Okay, not less than, it's much less than m2. For example, if I consider 10 kg mass, that is for m2, m1 is 0.1 kg we can consider, 100 gram, okay, 100 gram we can consider. So in this cases, no, V2 equals to 0. Simply you can say that if mass is heavy, second mass is heavy, not first mass, second mass is heavy, V2 equals to 0, but V1 equals to minus U1. Okay. So two special cases are there for the head-on collision. When mass is equal, V1 equals to U2, V2 equals to U1, and the heavy mass for the second one. In this case, U1 equals to minus U1. So V1 equals to minus U1 and V2 equals to 0. Okay. So small object rebounds, but heavy object it will be stay there only, no. Like a person is there with 150 kg, okay, for example, a person with 30 kg, okay, he is going and hitting the person. What will happen? Will he move? He will returns back, no? Yes or no? That's what they are saying. V1 equals to minus U1. Okay, why minus? Rebouncing back. Yeah, opposite direction. V2, I am staying there only, like is staying there only. Okay. Yeah, there is a question. Two ball bearings, each of mass 5 kg, are moving in opposite direction with equal speed of 5 meter per second. What they are saying? First thing is two ball bearing, no, M1, M2. Okay. What they are saying is M1 is nothing but 5 kg, M2 is nothing but again 5 kg. Okay. Opposite direction, no. One I will take like this, U1, and another one I will take like this, U2. They collide head on. They collide head on. Okay. Like after that, they are moving opposite direction. We will say. Find the final velocity of the ball in the collision. Can you find? 5 meter per second. That's it.
Yeah, same masses, so the velocities get U1 equals to V2 equals to U1, V1 equals to U2.
See, you are correct. 5 meter per second, but the direction are there, no? Both are in the opposite direction, no? If I consider U2 is like simply you take this the axis, no? This is positive y axis, this is negative. Positive x axis, this is negative x axis. If I consider U1, this is minus 5 meter per second, no? U2 will be plus 5 meter per second. Then what about V1? U2, no? Which is 5 meter per second. V2 will be equals to U1, which is nothing but minus 5 meter per second. Okay. So when you are seeing, no, like they are opposite in direction. Okay, if they are in same direction, no, I can say that both are 5 meter per second. When they are opposite in direction, no, that's why they have given the word opposite in direction. So I should consider 5 meter per second minus 5 meter per second. Okay. I'll give second question. You can try this question. A ball of 0.1 kg collides elastically with another ball. So unknown mass. Okay. What they are saying? First thing is mass 1 is given, that is 0.1 kg. Okay. It's like collides elastically with another ball of unknown mass. M2 is equals to, I need to find. So initially at rest, what it means? U2 is equals to 0. Okay. I don't know about U1. I will take U1 equals to U only. Okay. It's moving with U. So after collision, the 0.1 kg ball rebounds at 1/3. So 0.1 kg, no? This 0.1 kg. Okay. Let me take a diagram here. M1 and this is M2. Okay. M2 is at rest. M1 is at 0. What is?
1.
Yeah. This is U1 is equals to U only. Okay. This is 0.1 kg. Okay. So now it is going like this. After that it is rebounds back. So rebounds back, no. After collision, the 0.1 kg ball rebounds at 1/3 of its original speed. So originally I have taken u1 is equals to u. What will be v1 equals to minus u by 3, 1/3, no? After collision 0.1 kg mass, ball rebounds at 1/3 of its original speed. Find the mass of the another ball. The other ball I need to find. So v1 is given, no? v1 is given. I can use this formula. Yes. v1 equals to, I'll write here, v1 equals to, what is m1? 0.1 kg, right? 0.1 kg minus m2, I'll keep as it is, into u1 is u, right? v1 is minus u by 3, no? Minus u by 3. Next, plus, no? Plus, what is this? 2 into m2, I don't know, m2 will keep as it is. This is u2, no? u2 is 0. So overall 0, this one, okay. Divide by m1 plus m2, no? m1 plus m2. So this is cancelled, I can neglect it out. So minus u by 3 is equals to 0.1 minus m2 into u by m1 plus m2, where u1 u get cancelled. I can cross multiply, no, this one and this one. What it will be? This is 0.1, no? Yes, 0.1. So minus 0.1 minus minus m2, no? Minus m2 is equals to 0.3, no? 0.3 minus 3m2. It's not minus 0.2, it's 3m2. Yes or no? So from this I can write that 0.1 I can take that side, no? Yeah, this one 3m2 minus m2, which is equals to 0.3 plus 0.1. So 2m2 equals to 0.4, where m2 is nothing but 0.2 kg. Okay, understood, na? We'll go for the next one. Yes. So perfect inelastic collision. So in perfect inelastic collision, two bodies stick together after colliding and move with the same velocity. And before that we will see one more thing, head-on inelastic collision of two particles. Like we have seen the head-on elastic collision of two particles. Now this is inelastic collision. Okay, where momentum is conserved, total kinetic energy is not conserved. Okay, first point, momentum conserved. Second point, total kinetic energy is not conserved. Momentum conserved in the sense I can use the same equation, m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. Now here the formula changes for E, where v2 minus v1 by u2 minus u1, which is equals to minus E. Okay, or else I can change like E is equals to v2 minus v1 by u1 minus u2. Okay, u1 minus u2. So if I take this minus this side, no, I can multiply inside. So minus u2, minus of minus will be plus. So u1 minus u2. Understood? I should write it here. So v2 minus v1 by u2 minus u1, right? This is the equation given, which is equals to minus E. So if I take this minus this side, no, E is equals to v2 minus v1 divided by minus, if I multiply inside, minus u2, minus of minus plus. So u1 minus u2. Understood, no? This is about the formula for E. Okay. Next one is v1 and v2. So here if you see, no, m1 minus E m2, okay, and here m2 of 1 plus E. Okay, here the formula changes. You need to remember the formula for v1 and v2. Okay, you can take this formula, v1 and v2, m1 minus E m2 of u1 plus m2 of 1 plus E into u2. by m1 plus m2. Hi Rishabh, good afternoon, good afternoon. It's almost evening, man. Yes, we'll go for next one. Shayad, hi man. Okay, so perfect inelastic collision. So in a perfect inelastic collision, two bodies stick together, first point, after the colliding. Okay, so move with the same velocities. So only momentum is conserved here, no kinetic energy. Okay, in this case and previous case, no kinetic energy is conserved. So conservation of momentum. If two particles of mass m1 and m2 are moving with velocity u1 and u2 respectively. Okay, after collision, it is moving with same velocity, they said no. So it is v. Here body is moving with u1, mass m2 is moving with u2, but after collision both are sticking together and going with same velocity. Okay, that's what they have mentioned. Like they are sticking, no, they are not separate together. Okay, they are sticking, and m1 plus m2 is equals of v. Okay, so v is nothing but m1 u1 plus m2 u2 by m1 plus m2. Okay. So kinetic energy. Kinetic energy before collision, if you see, of m1 u1 square plus of m2 u2 square. But after collision, mass is there m1 and m2, but kinetic velocity is same, no, same velocity. So I can write like this, no. So kinetic energy final is equals to of m1 v square plus of m2 v square, where I can take v square commonly outside, right? m1 plus m2 of v square. That's what they have given. Okay. So loss in kinetic energy. So loss in kinetic energy means nothing but final minus initial. Sorry, initial minus final. Okay. Initially there will be some kinetic energy, and finally the kinetic energy changes. No. Yeah. There is the loss in kinetic energy. If you know to derive this equation, no, like directly you can write the equation here. So initially their kinetic energy is there. Finally some kinetic energy is there. So if you subtract both of them, you will get the loss in kinetic energy. Okay. So for this also special case is there. If target is at rest, target in the sense, see, mass m2, this is the target. So mass m1, I am throwing a mass m1 towards the mass m2. Okay. So which is at rest, then change in kinetic energy by kinetic energy, which is equals to, like initial kinetic energy, this is, okay, equals to m2 by m1 plus m2. Okay. So if target is massive in the sense, if this is greater and this is smaller, this is m1 and this is m2. So in this case, change in kinetic energy by initial kinetic energy will be equals to 1. Okay. Like what it means, like I am throwing the kinetic energy with kinetic energy, some kinetic energy, no, obviously the everything will be converted to the kinetic energy of the second body. That's what they are saying. So I can say that change in kinetic energy will be equals to kinetic energy, no, that's what its the ratio is 1. So 100% of loss in kinetic energy. So example, ball hitting and skidding on the wall. Yes, you can do this question. There is an example question. I will zoom it out. Yeah, you can do this question. You can try this question. A simple pendulum of length 1 meter as a wooden bob of mass 1 kg. Okay, like pendulum is there which is of length 1 meter. So if a pendulum is there, no, there will be a bob which is of mass 1 kg. It is struck by a bullet of mass 10 power minus 2 kg moving with 2 into 10 power 2 meter per second. So the bullet gets embedded into the bob. Find the height to which the bob rises. See, initially there is a pendulum, no, which is having of length 1 meter, which is having a bob, no, so which is going like this and come. Okay, suppose a bullet coming and hitting here, so mass will obviously increase, no. Now how much height it will go and come, they are asking. Okay. So initially there will be only one mass, but after that mass is adding. So I will consider this mass as bob mass m2. Okay, why I am considering m2 as, because a bullet is going and hitting the mass. Okay, so m1 is nothing but 10 power minus 2. Okay, m2 is nothing but 1 kg. This is 10 power minus 2 kg, this 1 kg. What is u? Two into 10 power minus 2. I need to find the final velocity first thing. Like I need to find how much height it is going, no? How much height is going. Like initially I am going with the kinetic energy. Okay. After striking into the bob, no, what will happen? The kinetic energy will change to potential energy, right? So I need to find first what is V. So then I can find what is H, no, what is the height. So kinetic energy will be equals to potential energy, no, right? So what is the formula of m plus m, because this mass and this mass, like bullet is going into the bob, no, so capital M plus small m, V square equals to m plus m into GH. So mm cancel. So where V square by 2 equals to GH, so H is nothing but V square by 2G. Okay, now I need to find what is V square here. So I can say that mu is equals to m plus m into V. So what is m here? 10 power minus 2, u is 2 into 10 power minus 2, which is equals to what is small, like capital M? 1 kg.
2 into 10 to the power 2, not minus 2. U.
Which one? Okay. This is 10 power 2, right? 2 into 10 power 2. So 10 power minus 2 into V. Okay, this is about the. So this is about V. So from this I can find V, no? So if I find V, I can substitute the value of V here. So then I can find what is the value of H. So from this we can wind up, okay? So remaining we can see tomorrow, guys. Okay, bye bye. Even sir.